Welcome to A-Level and AP Physics. In today's class, we will discuss past paper questions on waves from May-June 2022, paper 2. In this class, we will discuss waves, intensity, and Young's double-slit experiment. We will discuss these concepts in detail by solving past paper questions. So watch the video carefully and try to improve your conceptual understanding of these concepts. Let's study together. Let's improve together. For question number 5, part A, it is given to us light rays from the sun are incident normally on a magnifying glass. The magnifying glass directs the light to an area of radius r as shown in figure 5.1. The magnifying glass is circular in cross section with a radius of 5.5 centimeters. The intensity of the light from the sun incident on the magnifying glass is 1.3 kilowatts per meter square. Assume that all of the light incident on the magnifying glass is transmitted through it. For part A1, we need to calculate power of the light from the sun incident on the magnifying glass. Power of the light from the sun. So in this case, we need to understand intensity of light. Intensity is equal to power over area. But for this question, we need to calculate power. So simply we can rearrange this one. We can simply say power will be equal to intensity times area. Intensity times area. Intensity is given to us. The value of intensity is 1.3 kilowatts. So we have to multiply this one with 1000. And area we can calculate from here because the radius is given to us. And the radius is 5.5 centimeters. So we can say pi r square here, and we need to plug in value of radius. So intensity we have here, and pi is a constant, and we can multiply this one with radius square. So 5.5 times 10 to negative 2 square. If we solve this one, we will get value of power that is equal to 12 watts. So the answer for this question is 12 watts. This question has 2 marks. The first mark you will get if you have written this formula. If you have written this formula, you will get 1 mark, and that is C mark. And the second mark is answer mark. If you have got the right answer, you will get second mark. This is how marks will be awarded for this question. For the second part, it is given to us the value of R is 1.5 mm. We need to calculate intensity of the light on area A. So here we have R means the radius of this small circle is equal to R, and value of R is equal to 1.5 mm. And area of this small circle is equal to A. We need to calculate intensity of the light on area A. Already we have calculated power of the light incident on this magnifying glass. In this question, it is also given to us all the light incident on magnifying glass is transmitted through the magnifying glass. So it means that the power of the light reaching this area, that is equal to 12 watts, because no light is absorbed by magnifying glass. So the power of light reaching at this point is also equal to 12 watts. We need to calculate intensity, so simply we can use this formula. Intensity is equal to power of light, power divided by area. In this case, power is equal to 12, and area we need to calculate. So simply we can use formula pi r square because this is circular shape. So now simply we need to plug in values. We have pi here, and value of r is 1.5 mm. So we need to multiply with 10 to negative 3, and we need to take square of this. If we solve this one, our answer will be 1.7 times 10 to 6 watts per square meter, and this is value of intensity on area A. So simply we can write down our answer is 1.7 times 10 to 6. This question has only 1 mark, and that is answer mark. If you have got the right answer, you will get this mark. Now in this case, one thing you need to understand, that is the main concept. Power, you see, if power stays same and you reduce the area, intensity will increase. So the intensity of light at magnifying glass and intensity of light on this area A is different because area has been decreased, so intensity has to increase. Even power is the same, means same amount of energy per second is reaching this magnifying glass and also reaching this area, this smaller area, but here intensity is greater because area is smaller. So the intensity depends on area. If you reduce the area, intensity will increase. If increase the area for the same power of light, intensity will decrease. Very important concept, you need to understand intensity depends on area. For part B, it is given to us a laser emits a beam of electromagnetic waves of frequency 3.7 times 10 to 15 in a vacuum. We need to show that wavelength of the waves is equal to 8.1 times 10 to negative 8. First of all, we need to understand these are electromagnetic waves, means types of wave and type of medium. In this case, medium is vacuum and waves are electromagnetic waves. So the speed of electromagnetic waves in vacuum and in air is equal to 3.0 times 10 to 8 meters per second. So simply we can say this is speed of EM waves. Speed of all EM waves means from radio to gamma waves, they have the same speed in air and also in vacuum. So we can say this is speed of electromagnetic waves in vacuum and also in air. So this is the main concept you need to understand. Now we need to calculate lambda, but frequency of electromagnetic waves is given, that is 3.7 times 10 to 15 hertz. We need to calculate lambda. So this is what we need to calculate. So simply we need to use V is equal to F times lambda. From here we can calculate value of lambda. That will be equal to speed of waves divided by frequency of waves. Speed of waves is 3.0 times 10 to 8 meters per second and frequency of waves is given, that is 3.7 times 10 to 15 hertz. If we solve this one, our final answer will be 8.1 times 10 to negative 8 meters, and this is the wavelength of these electromagnetic waves. This question has 2 marks. The first mark you will get if you have used this formula, and the second mark you will get, that is answer mark, if you have got correct value of wavelength. So this is how marks will be awarded for this question. For the second part, we need to state the region of electromagnetic spectrum to which these waves belong. First of all, let's try to write down this one in a simpler form. If we multiply this by 10 and we divide this one by 10, there is no difference. So we multiply this one with 10 and we divide this one by 10. Simply we can say here we have this is 8.1. We can say this is divided by 10 and here we multiply with 10. So here we multiply with 10. So the power of this one is 1. If we simplify this, we can write down our answer here. We will get this is equal to 0.81 times 10 to negative 7 meters. So this is value of lambda. Now we need to find out region of electromagnetic spectrum. If you look at visible light, this is from 8 times 10 to negative 7 to 4 times 10 to negative 7. So it means this is not in this region. So this cannot be the region of electromagnetic spectrum, because this value is smaller than 4 times 10 to negative 7. Now if we go to ultraviolet, you can see the range of this one is from 3 times 10 to negative 7 to 8 times 10 to negative 8. So it means that this belongs to ultraviolet. So here we need to write down this belongs to ultraviolet. Simply you can say this belongs to UV. So the answer for this question is ultraviolet, and this question has only 1 mark, and that one should be B mark. If you have written ultraviolet, you will get 1 mark. This is how marks will be awarded. It's very important if you can remember this range of wavelengths. In multiple choice questions, most of the time they will ask you one question about EM spectrum. For our third part, it is given to us the beam from laser now passes through a diffraction grating with 2400 lines per millimeter. A detector sensitive to to the waves emitted by the laser is moved through an arc of 180 degrees. In order to detect the maxima produced by the waves passing through the grating as shown in figure 5.2, we need to calculate number of maxima detected as the detector moves through 180 degrees along the line shown in figure 5.2, and we need to show our working. We need to find number of maxima detected. So the first thing you need to understand, this question is about diffraction grating, and for diffraction grating we need to understand d sine theta. This is equal to n times lambda. For this question we need to calculate n. So first of all we will calculate only n, and then we will calculate maximum number of maxima. So if we rearrange this one, we can write down n will be equal to d sine theta divided by lambda. Now simply we need to plug in values and we can find value of n. We need to understand which angle we have to take. So in this case you need to understand angle is taken from the center maxima. Center maxima means from the center bright fringe. So if we draw the line here, you can see this angle is 90 degrees. So theta in this case is equal to 90 degrees. So simply we can write on here in this case the angle we need to consider for the maximum number of maxima or bright fringes, angle has to be 90 degrees. So theta is equal to 90 degrees. Wavelength we have already, it was given to us. Now we need to find out d. In order to calculate d, we need to understand d is equal to 1 over n. But for this question, it is given to us, we have 2400 lines per millimeter. So it simply means that we can write down this is 1 over, we have 2400 lines per millimeter. Or we can simply write down we have 1 millimeter that is divided into 2400. And other way to write this one, this is millimeter, we need to convert into meters now. 1 millimeter is equal to 10 to negative 3 meters. So here is meter, and this is divided by 2400. So this is the value of d. So simply we can say this is value of d. Now we need to plug in this value of d in the equation and we can find out value of n. Let's plug in these values. So d in this case is equal to 10 to negative 3 divided by 2400. We have sine of 90 degrees and value of lambda we have already calculated. That was 8.1 times 10 to negative 8. Now if we solve this one, our answer will be 5.2. So this is number of bright fringes on one side, but fringes cannot be 5.2. So only possible number of fringes we can have in this case is 5. So you need to understand number of fringes cannot be 5.2. Number of fringes can be 1, 2, 3, 4, 5, 6, 7, 8. But they cannot be. They has to be integer. They cannot be 5.2. So it has to be 5. Even for example, so let me give you one example. Let's say we got n is equal to 5.8. Again, you have to consider 5. So you have to round down. So you have to write down the next closest integer, smaller, not greater. So next one is 5. So we have to take positive integer, but it has to be smaller one, not higher one. So in this case, you have to take 5, not 6. Let's say if you got n is equal to 5.8, still you have to write down 5. So the number of bright fringes on one side of center maxima, in this case we have 5. So simply we can write down here is 1, and here is second, here 1 we will get third, and here we will get fourth, and here we will get fifth. So we have 5 here. Also there will be 5 on other side as well. So here also we will have 5 bright fringes or maxima. Question is asking us total. So we can write down n max will be equal to 2n plus 1. So this is the center bright fringe. So we can simply say this is 2 times 5 plus 1. So this will be equal to 11. So in this case, total number of bright fringes we will see on the screen, they are equal to 11. So the answer for this question is 11. So this is very important point because bright fringes cannot be 5.2. So only possible is they can be 5. Even you got answer 5.8. So bright fringes cannot be 5.8. They can only be 5. So you have to take the lower integer, not the higher one. Let me explain to you how marks will be awarded for this question. This question has 4 marks. You will get the first mark if you have written this formula. You will get 1 mark, and that is C mark. And the second mark you will get if you have written D is equal to this, and this is second C mark. And the third mark is B mark if you have got right value of n. And the last mark is answer mark. If your answer is correct, you will get last mark as well. So this is how marks will be awarded for this question. For the last part, it is given to us the laser is now replaced with one that emits electromagnetic waves with a wavelength of 300 nanometers. We need to explain without calculations what happens to the number of maxima now detected. Assume that the detector is also sensitive to this wavelength of electromagnetic waves. So this question is also about diffraction grating. So now we need to understand lambda has been changed. So first of all, let's try to find out. We have the previous value of lambda that was equal to 8.1 times 10 to negative 8. Now we have new value of lambda. So simply we can write on here lambda new, that is equal to 300 times 10 to negative 9. Now if we multiply this one with 10 to 1 and if we divide this one by 10, so we can simplify this one. So we have 300, this is divided by 10, and here we have this is 10 to negative 8. Now in this case we can cancel this 0 with this one, so we got this is 30 times 10 to negative 8 meters. In this case lambda nu is greater than lambda naught. It simply means that lambda has been increased. So the first thing we need to understand, in this case lambda has been increased. As lambda has been increased, simply we can look at diffraction grating equation. D sine theta is equal to n times lambda. From here we can write down n will be equal to d sine theta divided by lambda. In this case d is the same. We are using the same diffraction grating, and maximum angle is also the same. So if lambda has been increased, it means number of maxima will decrease. So that's all what we need to say. And this question has 2 marks. Let me show you how you can write down your answer. So this is how you can write down your answer. If you have written lambda has increased, you will get 1 mark, and that is M mark. Then if you have written number of maxima decreases, you will get 2nd mark, and that is A mark. But if you have written number of maxima decreases, but you haven't explained that lambda has increased, you will not get A mark, because you need to get first of all M mark, then you can get A mark.